Okay, so we're looking at number 2, where I have 3z equals, oh, I'm sorry, excuse me, 3z minus, I've got a 2 by 2 of negative 20, 15, 7, and negative 9. And that is going to equal 12, negative 3, 19, and 6. Okay, so what I'm going to first have to do, again, I need to get the variable alone. So I'm going to go ahead and add this matrix of the negative 20, 15, 7, and negative 9 to both sides. Okay, and please notice that because I'm adding or subtracting these matrices, okay, like in the first one, I did have to go ahead and subtract the matrix from both sides, and here I'm adding, but if you notice, I don't change the sign within unless I end up subtracting and I need to add the opposite. Excuse me. So that matrix eliminates, and now I get 3z equals, and I'm going to have a 2 by 2. So 12 plus negative 20 is negative 8. Negative 3 plus 15 gives me a 12. 19 plus 7 gets me a 26. And then 6 plus negative 9 is a negative 3. So I'm good there. So now what I need to do is, again, to get that z alone, excuse me, I do need to divide every single component by 3. Okay, so I get z equals a negative 8/3. 12 divided by 3 is 4. 26 divided by 3 is 26/3. And negative 3 divided by 3 is negative 1. And that is what I get for z there. Now, one big thing that I am very particular about is being exact. And that, like the negative 8/3, you could technically say that that's negative 2 2/3. Or I would even take negative 2.6 repeating, like this, okay? I would even take that because that is accurate. However, if you try to do like a negative 2.7, rounding to the tenths, that's inaccurate, and I will not accept that. So that's something very, very important to know. You want to be as precise as possible, and I know that not everybody loves fractions. However, fractions really are the best thing that you've got because they are 100% precise, unlike decimals. I just always like to say, you can multiply 2/3 times 1/3, but can you please tell me how you're going to multiply 0.6 repeating times 0.3 repeating? Yeah, you probably aren't, okay? Now, I know how to multiply those and to be able to get the right answer, but y'all probably don't because you haven't minored in math. So, just keep that in mind, folks. All right, so now we're going to look at number 3. Number 3, I actually have a 1 by 4, so it's kind of skinny looking. So I have 6, negative 2, 8, and 5 minus 4x. And that gets me another 1 by 4. That's going to equal 3, negative 2, negative 6, and 2. Okay, so it's a little bit funky to kind of see a 1 by 4. It almost looks like you're trying to do like a 4-digit number or something. So my goal is to get that negative 4x by itself. So in order to do that, this matrix in the front is technically being added, so I have to subtract it. So I have to subtract 6, negative 2, 8, and 5 from both sides. So I have 6, negative 2, 8, and 5. So then I end up with negative 4x equaling, and I do need to add the opposite. So I'm going to go ahead and change all of those signs to add the opposite. So 3 plus negative 6 is negative 3. Negative 2 plus positive 2 gives me 0. Negative 6 plus negative 8 gives me negative 14. And 2 plus negative 5 is negative 3. So now at this point, I need to get x alone. So I am going to divide everything by negative 4. Alrighty, dividing. So then x is going to equal negative 3 divided by negative 4 is 3/4. 0 divided by negative 4 is 0. Negative 14 divided by negative 4 reduces to a 7/2. And negative 3 divided by negative 4 is 3/4 here. So at this time, I have completed and I've solved for x. So that is the general gist of solving matrix equations. So You have to understand multiplying a matrix by a scalar, like the very first problem that we did, because when you solve matrix equations, you basically are undoing the multiplication by a scalar whenever you have to divide each and every component by that. So kind of keep that in mind as you practice through your problems, and you will do great.